Alright, so now we're going to look at integrals involving partial fractions where there are repeated zeros for the denominator, alright? So, the first thing we want to do here, well, we're going to take this 3x plus 8 and we're going to turn it into two fractions. And we need to know what the factors of the denominator are. So actually, let's just factor it right away. The factors of the denominator, well, you have two factors of x plus 2. The denominator is actually x plus 2 squared. It's a perfect square trinomial. So what we want to do, this is how you're going to deal with repeated factors. Here's a repeated factor. It's repeated twice. So the first fraction, we're going to put a over that factor that's repeated, and then we're going to put b over that factor raised to the second power. Now, if this were a third power, I'd put plus c over x plus 2 cubed. If this were a fourth power, I'd put plus d over x plus 2 to the fourth power. So you keep adding terms until you reach the power that is the number of times that it repeats. This one only repeats twice, so I only need these two terms. Okay, that's great. Now, once again, we're going to multiply everything by the LCD. If you the LCD is x plus 2 squared. If you multiply this by x plus 2 squared, you're left with just 3x plus 8. If you multiply this by x plus 2 squared, one of the factors of x plus 2 cancels, and you're left with a times x plus 2. And if you multiply this by x plus 2, the only thing left over will be b. So we get this equation, and now I'm going to try to figure out what a and b are. So let's see, I can plug in a -2 to cancel that factor out. Let's see, so let x equal -2. If x is equal to -2, this is 3 times -2 plus 8 on the left hand side, and on the right hand side is a times -2 plus 2 plus b. Let's see what happens here. -2 plus 2 just turns into a 0. 0 times a is 0, so I get b on the right hand side. 3 times -2, well, that's -6, and -6 plus 8 is 2, so b is equal to 2. Once I find out that b is equal to 2, I can actually find out what a is. Here's the thing. I don't have any other factor to plug in because x plus 2 was the only factor of the denominator. So to find b, I'm not going to be able to do it using that trick. So to find b, this is what I have to do. Sorry, not b, to find a. To find a, this is what I have to do. I'm going to have to match up the terms on this side with whatever terms come out on this side. So let's see. I have the 3x plus 8, and this is equal to, I'm going to distribute the a. So this is going to be a x plus 2 times a. And then plus b, but I already know that b is 2. So plus 2. So this is what I get when I just distribute the a, and I replace b with what it equals, the number 2. Now here's what has to be true. The coefficient of x on the right-hand side has to match up with the coefficient of x on the left-hand side. So since I have this term and this term are the like terms on opposite sides, their coefficients have to be equal. And 8 has to equal 2a plus 2. So here are two things that have to be true. This 3 has to equal a. 3 has to equal a. So we already have found a. But even if we didn't, we also have another equation. 8 has to equal the constant, the thing that doesn't have an x over here. Well, that's 2a plus 2. And in either case, if you subtract 2 here, you get that 6 is equal to 2a. And if you finish solving it, you get that a is equal to 3. But we already knew that because we had this. Okay, so now I figured out the partial fraction decomposition of the fraction in this integral. So let's go ahead and change it. So this integral is now going to be the integral of a over x plus 2, but a is 3. So 3 over x plus 2. Then plus, and then it's going to be b, which is 2 over x plus 2 squared dx. So this is what I'm integrating, partial fraction. So I'm going to do each integral separately. This is going to be the integral of 3 over x plus 2 dx plus the integral of 2 over x plus 2 squared dx. This one here, well, I can do a substitution there. Let's go ahead and do some substitutions. I'm going to let u equal x plus 2. In that case, du would be, well, the derivative of this is just 1, so du would be equal to dx. And I'm also going to let v equal x, oops, well, I don't have to do that. I already have u equaling x plus 2, and the other integral also involves x plus 2. So I can do only one, I can afford to only do one substitution. So let's see here. I can bring the 3 out to the front of the integral. Then it's going to be the integral of 1 over u, and then dx is du. So that one was relatively easy. Then plus, the 2 can come out to the front, the integral of 1 over u squared du. So I can do each of these integrals separately. This one gives me, well, it's 3, and the derivative, or the integral of 1 over u du is the natural log of the absolute value of u. Then plus, this one, well, that one is actually u to the negative 2 power. So when I take the antiderivative of that, I add 1 to negative 2, I get negative 1. So I'm dividing by negative 1. And I raise u to that power, negative 1. And then I still need the plus c. So integrating that gives you this. And that makes this answer this. Let's see, we have 3 times the natural log of the absolute value of u. Well, u is x plus 2. And then minus 2 over negative 1 is minus 2 times, well, that's 1 over u, or that's actually x plus 2 to the negative 1 power plus c, and then we just clean that up by getting rid of the negative power. So the final answer is 3 natural logs of x plus 2 minus 2 over x plus 2 plus c. And there, that is how we do partial fractions when there are repeated zeros in the denominator, repeated factors in the denominator.